This is On-Course Rating Systems, a unique tool for coaches, athletes, or anyone interested in cross-country to help make sense of race performances. It will provide the answer to the cross-country athlete who asks, "How well did I race today?"
Hi, I'm John Tucker, head coach of men's cross-country at Washington and Lee University and director of On-Course Rating Systems. If you coach or run cross-country, I bet you'll agree this is the greatest sport on earth. The thrill of racing through woods and over hills and fields is unmatched anywhere in athletics. The type of individuals that excel as endurance athletes, the lessons we learn through pushing ourselves to our limits, and the variety and beauty of these unforgettable courses make coaching and competing in cross-country a true privilege. But this great sport has an old problem. You can't really answer that athlete who asks how well he or she raced. Meet results show you your order of finish and time, but unless you race on a precision-measured, perfectly flat course, it's hard to know just how competitively you ran, or what paces to target. In track races, you can plan and see your exact pace per mile or a fraction of a mile, and if you underperformed or overreached. With each race, your potential at that distance gets clearer, as well as how competitive you were compared to other runners not even in the race. Learning the same things from a cross-country meet, on the other hand, has been virtually impossible for several reasons. One of which is precisely that every course is different. Some courses are flat and fast, while others are hilly and challenging. A superior running performance on an extremely difficult course might look average compared to a truly average performance on a flat and fast course. Another problem making sense of cross-country performances is the inaccurate and inconsistent measurement of courses. How many times have you suspected a course of being long or short? Surprisingly fast or slow times frequently are attributable to short or long courses. The reason track performances are universally understandable is that they're all performed on the same precisely measured, uniformly designed and surfaced course, a 400-meter track. We know that a performance on one track would produce about the same time on any other track if performed that day by the same athlete with the same energy in the same conditions. But identical times on different cross-country courses seldom mean identically competitive performances. The key to being able to compare cross-country performances is to convert them to a universal common standard, their equivalent on a track. Tracks are the least difficult courses on which to run an endurance race. They're the common standard to which all cross-country performances can be compared. If you could measure the energy you use in a cross-country race and then apply the same energy for the same distance in the same conditions on a track, your performance would suddenly make sense. You would know exactly how well you ran. Any cross-country performance becomes universally understandable once converted to its track equivalent. That is the kind of information that On-Course Rating Systems provides, so you can finally tell your athlete just how well he or she ran, how they stand versus their competitors, and help them accurately target paces on courses of varying difficulty.
Our goal is to help you evaluate and compare cross-country race performances. For that to happen, accurate course measurements are essential. We know, for example, that at a fairly competitive pace, it takes a runner about 8 seconds to cover 40 meters. So you could not make a valid comparison of a runner's performance on a 7,960-meter course to another at 8,040 meters, thinking they were both 8K races, without an unacceptable margin of error of nearly 16 seconds. Yet it is not unusual to see length discrepancies of as much as 100 meters on a cross-country course. A way to measure cross-country courses accurately and consistently had to be found. While searching for the most simple, accurate, consistent, affordable, and available method to measure cross-country courses, OCRS looked at GPS systems, laser technology, bicycle computer chips, and of course, the almost universally used click wheel. Soon it became obvious that every system had built-in, if not prohibitive, problems. GPS technology might be the ideal way to measure if the course is wide open and flat, but problems arise when there are hills and trees. Trees block the satellite signal, making it impractically slow, and currently GPS is only 1/4 as accurate in the vertical on hills as the horizontal, meaning that measurements on a course with substantial elevation change would likely be inaccurate. Bicycle computer chips are affordable, available, and are, if great care is taken, a fairly good way to measure courses. However, tire pressure, the temperature, the ability to ride in a straight line, and diligence and calibration are all problem areas with accuracy and consistency using bicycles. Lasers and other precision instruments, such as those used by surveyors, are amazingly accurate to within a fraction of an inch in miles, but they measure only in straight lines, again making that technology prohibitively time-consuming and expensive to measure a course with any curves or hills. The familiar click wheel, by which virtually every course has been measured, is probably the least accurate of all. In 2006, OCRS completed a thorough study of the wheel, comparing controlled measurements of the wheel to precise tape-measured distances on a variety of typical surfaces found on cross-country courses. Surfaces tested include short, medium, and tall grass, both wet and dry, bark, chips, dirt, gravel, sand, and even paved roads and track surfaces. In repeated tests at 100 meters on those surfaces, the wheel showed inaccuracies of between 1 and 19 feet. The greatest error occurred on sand and gravel, and the least on the track. The surprising thing about the wheel was its consistency. While discrepancies of 3 to 5 feet were not unusual, again in only 100 meters, they were observed in several tests in a row on the same surface. Understandably, seeing identical readings by the wheel 3 consecutive times would naturally convince a diligent coach his measurements must be correct. Yet many wheel-measured courses have length discrepancies of as much as 100 meters. More details about the click wheel study can be found by clicking the articles link on the OCRS website. What should you use to measure cross-country courses? After much trial and error, OCRS finally found the device that was easy to use, accurate, affordable, and already in every track team's equipment locker. It's the long tape reel used to measure throws in track and field meets. Let me guess what you're thinking. Pull a tape measure around the entire cross-country course? You've got to be kidding. We admit that at first it may seem a daunting task, but having done this now for several years, OCRS has developed a method, which you're about to see, that will allow you to precision measure an 8,000 meter course, for example, in about 4 hours. After using the OCRS method, we're confident you'll find it will provide far greater accuracy while taking no more time, perhaps less. Astonishingly, there are no standardized specifications for measuring high school or college cross-country courses. The NCAA, for example, requires that courses be 6K, 8K, or 10K, etc., but provides no guidelines for how that is to be done. One advantage for OCRS courses is that they are all measured using the same method, the one you are learning in this video. The OCRS method is simply to pull a tape measure around a course on the line a knowledgeable lead runner would run, or simply the shortest route. In this illustration, notice that the runner's line is a straight one between curves and tangent to those curves. Notice also that he or she does not run on the inside boundary of the course, but 12 inches inside that boundary, the 12-inch setback, just as he or she would on the inside lane of a track. Let's get started. Here's the equipment you'll need. First, you need 20 brightly colored wire flags cut to 12 inches in length. The 12-inch wire lengths will be useful, for example, when you're measuring curves. Shortly you will see how curves are measured using a 12-inch setback from the inside course boundary. The flags will give you plenty of visual references to accurately place that 12-inch setback. You also need to keep track of these flags, counting them regularly. The best way to count them is to turn them upside down and count the wire ends. You'll find that this is a quick and easy way to keep track of your flags. You'll also need some extendable magnets. They're inexpensive and readily available at pretty much any hardware or building supply store. These extendable magnets will be useful to you because it'll enable you to place the flags on the ground without stooping by merely stepping on the flag and walking away. You're also going to need a tape measure. These are found anywhere. You want a tape measure that's 50 meters in length. If you have a metric, that's the one to use. If you don't have a metric, you can use an imperial. You just need to make a mark at the 164-foot 1/2 inch mark, which is also 50 meters. And regardless of which kind you have, flip it over and make a mark on the other side, the blank side of the tape. Now you may be asking yourself, shouldn't we be using a steel tape? If you have a steel tape, of course, that's fine, but you don't have to have a steel tape. Refer to the click wheel article mentioned in the introduction to see why it's perfectly acceptable to use a fiberglass tape. When measuring straightaways, there'll be two measurers, one at each end of a 50-meter tape. The front person will have all 20 flags to begin with, and when he reaches the 50-meter mark, he will place the flag and continue along the runner's line. After a flag is placed, and the front measurer continues along the runner's line, the rear measurer will allow the zero end of the tape to be pulled just past the flag so he can remove the slack while pulling the zero end back to and picking up that flag. Let's talk about how to measure the curves. Some curves are so slight and gradual that the front man will be able to lay the entire 50 meters of tape down on the runner's line with no delay. Tighter curves require a little more time and care. When you encounter a curve that is too tight to do in one coordinated motion, like the straightaways, the front man will have to place the reel on the ground temporarily and walk back to a point where he can pick up the tape and place it on the runner's line in segments. During this process, the back man initially holds the zero end of the tape but will move up to the good to hear point or segment that the front man has just finished. Repeat this process until the curve is finished and the front man can place the next mark. Again, the important thing is that the tape be carefully laid on the runner's line and that the slack be minimized. While you're taking the time to precision measure your course, you'll also want to locate your K-marks and mile marks. K-marks are easy. They occur on every 20th place flag or after you place the last flag in your bundle. Locating mile or 1600 meter marks is also easy but requires a bit more care. We recommend using 1600 meter marks instead of actual mile marks, which are another 30 feet 4 inches beyond 1600 meters, because the 1600 marks will fall exactly where you'll be placing your flags, saving time, and because there are exactly 5 1600 meter segments in an 8K, for example. The first 1600 meter mark will be at the 12th placed flag or 600 meters beyond the 1K. The 3200 will be at the 4th placed flag or 200 meters beyond the 3K, etc. Keep track of the number of flags you're holding by turning them upside down and counting the wire ends. Have your K marks and 1600 meter marks pre-numbered and on different colored flags for men and women, and carry them separately from the bundle of 20 unmarked flags. Flags are temporary, so you should preserve these important locations on your course with more permanent markers. With just a little preparation and follow-up before and after you go out to measure your course, you'll have everything you need to get your course in the system. And best of all, you won't have to do it all over again next year. As you near the finish line, continue measuring and placing flags until you have finished the entire 5K, 8K, etc. Once you place your last flag, measure the distance from it to your finish line to see the exact length of your course. Don't be surprised if you see a significant length discrepancy. Courses are frequently found to be longer or shorter by as much as 100 meters. Remember that all courses are inaccurately measured to some degree. See the ClickWheel article to see why. Finally, if you carefully follow the measurement methods described in this video, you will have one of the most accurately measured courses in the world, performances on which can be reliably compared to those on any other rated course. This is in part because all OCRS courses have been rated and measured the same way.